Hello.
Hello. Hello.
All right, so let's take a look. Find the area A of the region enclosed by the graphs. Hey, shh.
I'm trying to explain
Okay, but shh. Yeah, a little bit. All right, so region enclosed by the graphs y equals sine x and y equals cosine x from the y-axis to their first point of intersection in the first quadrant. Okay. Okay, so let's see. Where are these things going to be equal? So if I'm starting at the y-axis, right? What is the x value at my y-axis?
I'm from 0 to positive infinity. Oh,
X value.
Y, X value or Y?
Yeah, x value.
Yeah, the first quarter is from 0
Yes,
to
yes. And so I start at 0, right?
Yeah.
The y-axis starts at 0. And so I'm only going to be dealing first quadrant stuff that's going to be positive. So if I want to think about this, I'm going to start by doing a little sketch. Okay, so this goes to the 1, this goes to -1. So sine starts here, and it goes up. And so it goes like this, so it's going to go up to 1, down to 0. This, ooh, almost got it. Ah, all right.
It's a random ball.
Pi, this is pi over 2, right?
You were the one who left it first.
Okay, so next one,
And the next one is gonna
that's sine. Now cosine starts where?
at 1 to the pi over 2.
And it goes 1, starts at 1, and at pi over 2 it's
0, 0.
0,
And then 2.
and it goes to -1 here, right?
Yeah.
All right, so right here is the point of intersection, isn't it? So if you know your unit circle, I know that sine and cosine are both equal where? At what?
What was the question?
Where is sine and cosine equal?
At that one where the intersection.
Yes, I know where. What is that?
Pi over 4.
Pi over 4. Okay, so pi over 4. So we know that my bounds in this case are going to be
From 0 to pi.
0 to pi over 4. So let's take a look. So I'm going to go from integral 0 pi over 4. Which one's on top?
Cosine.
Cosine. So it's going to be the cosine of x, right? And it's going to be minus
Sine.
sine of x dx. Now it's time to do some integration. Remember, the derivative circle goes clockwise. Integration circle goes counterclockwise. All right, so let's go ahead and take my integration of this. So the integration of cosine is going to give me sine of x. Integration of negative sine x, because there's a minus in front of it, cosine. So it's plus cosine x from 0 to pi over 4.
But aren't we like when we do this, we're like separating into different integrals?
We could do that too, but it's fundamental theory of calculus. We could either have them combined or we could separate them individually. So it's going to be the same thing. So right here, so let's take a look. So sine at x is going to be rad 2 over 2. So it's going to be minus, lower bound, sine at 0 is 0, cosine at 0 is 1. So it's going to be, let's see, I'm going to end up with, as I add those together, it's going to be 2 rad 2 over 2, which is just rad 2, and this is going to be minus 1. Yeah, that's the area in between those two curves. So if I want to approximate it, so what is rad 2 minus 1?
0.238. I bet it's gonna be
Yeah, do the-
0.238.
How much you wanna bet?
0.3. Okay, who's the closest one? Who's the closest one? Okay, 0.238.
0.234.
Oh, I said 0.3. I was the
0.4.
Yes.
Ah.
I said
Yeah, small dog. One like
I
you.
said
Okay, so
0.414.
let's check the math. Numerical. So it only works when I could do a numerical bounds here.
I didn't even hear the joke here at all, Just so
All right, so let's see what we get.
Football. Yeah, baseball, football, right?
They have wrestling with wrestling and wrestling like.
Did I do it right?
Looks like
Quite
it.
possibly.
You better stop.
You better stop here, right? It's like,
Did I do it right?
yeah.
No.
Yeah.
No.
Yeah, but we have.
All right, come on.
Just,
Yes.
Just press enter.
Cool.
Yes, thank you. Whenever I'm pushing,
Now it matters?
yes, why would it matter?
You've got
Because-
degrees.
Oh, 'cause
You
that's
have
the
it's
degree.
supposed to be
Because I'm
degrees
putting
too, so
sine and
it's
cosine into the calculator, right?
Yeah.
degrees.
That's where it does matter.
It's radian.
Okay, so let's go ahead. Settings, document settings, radian. Do it again.
Ew.
Oh yeah.
There we go.
You're welcome.
It's happiness.
It was actually me who told her, but I.
Oh, thank you.
What a lie.
Laugh is so
Yeah.
Stop lying for once.
So
I'm tired of your lie.
I actually changed everyone's calculators to degrees at the beginning just to do this.
Really?
Radian,
Yep.
mister.
That's
Are you
really rude.
serious?
Mine's in radian, mister.
Oh, now they're all radian.
Oh.
Are they?
Yeah, now they're all radian.
So
No, not mine.
that's one of the big things you have to make sure every time.
What's that? Drops. What labels? What the hell is
Take a
that?
piece.
All right.
Wait, this is.
Now, in this case right here, where
Oh. Okay, sorry.
in this case right here, now we're finding the area enclosed by the graphs, but these are according to the y-axis. Instead of finding the area below the function down to the x-axis, we're now going to be doing it below the function according to the y-axis. So it's going to be how far it is away from the y-axis now for all of these. So let's start off. Same thing. What do I got to do with these things?
Set them equal.
Set them equal. So it's going to be y plus 2 equals y squared. 0 equals y squared minus y minus 2. So that's going to factor out to be y
I think it's gonna be y minus 1 and y plus 2.
minus 2
Yeah,
plus 1.
Like,
What's
it's
negative?
same if you would put it different. Or no.
Yes, that does matter. Did I do it too quick?
I'm just gonna do this.
Okay, so we're factoring it. Alright, so what two numbers give me negative 2?
Whatever. Or negative one.
Yeah, so because it's negative, my numbers have to be a positive and negative, right? I can't have two negatives, I can't have two positives, because they'll both give me positive, right?
I'm just confused with the white part, like the middle white.
This one right here?
Yeah.
Okay, so, hold on. Let me fix this right here. Alright. So, they're set them equal, right? Okay, so subtract y from both sides. Subtract 2 from both sides. So now, only, hey. Okay, so 0 equals y squared minus y minus 2. Okay? So now, these two right here, so this 2. The only things that multiply to be negative 2 is negative 2 and 1, right? Or negative 1 and 2, right? Okay, so when I add them together, they have to give me negative 1. That means that it has to be a negative 2 times a positive 1. So I add those together. So I multiply it, I get negative 2. I add those two together, I get a negative 1. And that's what I was looking for here, the negative 1. Okay, so now I get y minus 2 and y plus 1. Alright, so we get those. And now, so what does that give me? That gives me a balance, right? So now it's going to be y equals 2 and y equals negative 1.
Bluetooth disconnected. Bluetooth pairing. Bluetooth connected.
Restarting.
We're talking about theorem. No, I was just trying to explain him. I'm sorry.
Okay. Alright, so now we have that. We have it set up. So now I'm going to have an integral, right? And it's going to be from negative 1 to 2. But now, these are not x's, these are y's, right?
Yeah.
Since these are y's, I'm going to have a dy.
Like dy, yeah.
dy, because I'm taking integration in terms of y this time. So now I'm going to have a dy.
But why?
Now, let's see what my graph is going to look like. So I'm going to sketch a graph. So sketching a graph, I know that I'm going to have y squared. So where y is positive, so I'm going to have this. So it's going to be a parabola going this way, right?
What's that?
It's a parabola.
Parabola.
Oh, I see. Yeah, because it's, wait,
The sideways parabola.
but isn't it supposed to be only one line?
No.
It's a
Because it's like,
parabola.
if you rewrite it, it's gonna be like y equals square root of x.
But we're not rewriting it. We're doing it in terms of y now. So that's the graph of the function y squared. Now, let's take a look at the other one. It's going to be y plus 2. So at 0, so just to graph this, I'm going to do it slowly. So let's say, alright, so let's see. I'm going to have when y is 0, x is 2. So it's going to be right here. Alright, and so when y is negative 1, x is positive 1. When y is negative 2,
Wait. Y is negative 1, so it's the point.
when y is negative 2, x is 0. We're doing a function backwards. We're solving for x's now. You don't need to turn it that way because it's
It's like, yeah, but you just said that if y negative 1, so it means that y is supposed to be on the bottom, isn't it?
Yeah.
When y negative 1, x
Yeah.
is 1. But you put a point on y 1 at x 1.
it's the inverse of the function.
So do we have to look then like that?
Yes, it's the inverse of the
Okay.
function.
That's why I was trying to look like that, because, you know. So you basically say that x-axis is y and y-axis is x. What is
It's
Oh,
supposed
you
to
made
be
this
facing
line
like
either
the
way.
It's really hard to sing.
Your second graph is supposed to be like y squared and y.
y squared, right?
Yeah.
Y,
One's y squared.
like,
one's
there's
y
one is y squared and the other one is y plus 2. Okay.
And the other one is x equals what?
y plus
Y
2.
plus 2.
So if it's whatever.
Oh, you were
See,
right.
that's what I was
Oh,
saying.
See, you see?
I'm saying you that it's like.
I'm saying you. All right,
I'm
good.
saying you.
I'm saying you.
Okay, you're right. That's why I wanted to go to the graph.
They just keep taking my thunder.
He's just
What?
teaching, we know what we're doing.
Okay. All right, so now we're finding the area bounded by these two functions. So bounded by the two functions, so it's in between -1 and 2. So in that whole thing, it's only going to cross here and here, right?
Yeah.
Okay, so since it's crossing here and here, so that's why I have my integral set up. So that means it's going to be the red line minus the blue line, right? Because I'm doing it in terms of the y-axis. So how far it is away from the y-axis now. That's the dy. That's my delta y, the change in the y-axis here. Are we okay?
Maybe. Yes.
Okay, here.
Whoa,
Uh.
whoa, 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 whoa.
That's for me.
Huh?
He's still wearing
I know, because he was right. So I had to,
I was right
r-
about the rat.
What are those?
huh?
I was right about the rat.
The rat?
Rad.
There was a rat?
Rad.
No,
Rad.
on that one, okay. So I changed everyone's calculators for that reason to make sure you guys actually make a mistake on that one. That's what I was waiting for. So I was sneaky. That one was intentional. The one from Bo is unintentional.
I wouldn't do anything.
Wow. Wow. All right. So on this one right here,
Those are good. Thank you.
you're welcome. Thank you for following along, paying attention, and catching my mistake.
You're welcome.
Okay.
I figured you knew what you were doing, otherwise I'd have got the
No, I do it like sometimes I do make mistakes, and so that's why I throw out candy.
Like my
Anyway, all right. So which one is the one that's going to be my top bound?
The y plus 2.
Y plus 2. So it's going to be y plus 2 minus my lower bound, which is
Y squared.
y squared. Yes? Are we okay?
Yeah.
Okay.
He's just enjoying his cookies.
Okay. Good.
They're so good. It's like a cookies with Nutella inside of it.
Nutella.
So I'm going to rewrite this 2 plus y minus y squared dy. I just rewrote it so it's in numerical or in order according to the degree. So you didn't have to, but when I do my integration, just a little bit. I like order on occasion. Do the integration, so this is going to be 2y plus y squared over 2 minus y cubed over 3 from -1 to 2. Do the math. Let's do the upper bound. So it's going to be, what's that? 4 plus 2 minus 8 over 3, right? Minus my lower bound, which is -2 plus 1/2
Minus 1.
plus 1/3. And let's do the math on this one. It's going to be 6, right? So this is going to be 24 over 6 plus 12 over 6 minus 16 over 6 plus 12 over 6 minus 3 over 6 minus 2 over 6. There we go.
Okay, so it's gonna be 36, 20, 32, 31. Oh wait, no, 29 and minus 2, 27 over 6.
I don't know. I'm hoping you guys figure it out.
Yeah, it's 27 over 6.
You guys going with what he says? Or you guys actually doing the math?
What do you get? 27 over 6? 27 over 6? Yeah, that's what I got.
But I think you made a mistake. Because you see, 4 plus 2 is 6, and 6 over 6, you need to multiply it by 6, it's going to be 36 over 6.
What?
What?
No, he just rewrite it. 4 is 24 over 6 and 2.
Yeah, what's 4 divided by
Oh, yeah,
6?
yeah, I see, 36, yeah.
Yeah, just common denominators.
So it's 27 over 6.
You guys agree?
I thought it was 10.5, 10.5.
Agree. Okay.
I don't agree.
You disagree? Anyone in the court who disagrees, get up and do the class.
And if you're wrong,
Also, I think I'm
I'm
you're
gross.
wrong.
If I'm wrong, then what I'm gonna
Because I
get?
get
You have to give me cookies.
Can I
You'll
get
give me
cookies?
call cookies.
No, you, Bo, have to give it.
I don't have cookies.
Well, you have to go find some.
36 minus 16 is gonna be.
yeah, 10.6 or 10 point.
10.5.
Yeah. Okay. So 10.5. Still right.
No,
Yeah.
I got 0.
You got 0 point what?
No, never mind.
Wait.
27 over
Wait, how
6
is 27 over 6
4.5.
supposed to be 10.5?
It's supposed to be 10.5.
No, it's not 10.5. There's no way it is 10.5.
There's no way.
Because
I got
because if to
4.5.
get like 10.5 times 6 is gonna be 60, not 27.
I got. What did I? Yeah, I erased it.
Are you sure?
I got 27 over 6.
But then
Same.
that is, yeah, it's 4.5, 9
Yeah.
over 2.
Not 10.5.
9 over 2.
Yeah, 9 over 2.
So I was wrong. What was it?
It's 9 over 2. Thank you for someone else to actually do the problem.
You're welcome.
I appreciate it, and you know it.
Wait, but 27 over 6
It was
is 9 over
27 over
2.
6 and then 9 over 2
Yeah,
and
this is
then
why.
4.5.
This is
Like
why.
same, but
I needed
whatever.
10%.
I was right.
Good job.
So why did
What do
you
I
say?
get?
Okay.
Where's
So why did you
call
say
cookies?
10.5 when you calculated?
Actually, you owe her a cookie because she
Yeah.
just proved you wrong.
Wait, I was right. 27 over 6 is the same as 9
No.
over 2.
No, it's not.
Okay.
Yes, it is. Multiply by 3 both
It's not the
top
same.
and bottom.
Yes,
It is.
It is.
Anyway, I'm gonna save the rest of this for tomorrow.
Okay. That's
Or not tomorrow.
Tuesday.
Monday.
I'll be here
Tuesday.
Monday.
There's
Tuesday.
No Monday.